Wow! Hello, everybody, again. Welcome back. So funny, the technical difficulties this evening. Let me know that sound check. Can you guys all hear me? Make sure you can hear me, you can see me. I'll be screen sharing going back to M51 in just a moment. We're back, TXR, amazing. Hello, everybody. Awesome. We're talking about moon cakes. That sounds yummy. Okay, perfect. You can hear me. Great, great, great. That is awesome. Okay, well, let's go back to what we were looking at, which was M51. Although, actually, I just moved the telescope to, we can go back to M51, but we actually jumped ahead to another galaxy. But we'll just enjoy that for just a moment. Take a quick photo to M51. Anyone want to pick up from what we were talking about with M51? So funny. Look at that. Oh, by the way, I just want to share that in the top left corner of the screen, you can see a totally different date. Just so you know, it's not Tuesday, January 9th at 9:41 a.m. Just another odd thing whenever my iPad plugs into my computer, it changes the date like that. But let's back to M51 that we're looking at right here, which is the Whirlpool Galaxy. We'll wrap up on the Whirlpool Galaxy and then we'll head to the live viewing of Bode's Galaxy, which is the next one that we will be looking at. M81, even better. Yes, amazing. The Whirlpool Galaxy, Mateo Fernandez. So, yeah, recap. What is the Whirlpool Galaxy? Anyone want to share some stuff in the chat? What were we talking about it? Why is it Athena's personal favorite and a lot of other fan favorites in the chat here? I mean, I think every stargazer, we absolutely love looking at the Whirlpool Galaxy. I also just love the name because it does really look like a whirlpool. If anyone, I mean, we're going into summertime. If anyone goes into a swimming pool and you get a bunch of your friends and you guys start to kind of run in a circle or swim in a circle in the pool, you start to create a whirlpool. And I just love this because it really, truly does look like that. So you've got a giant spiral galaxy and a small dwarf galaxy that are beginning to merge. Now, something really cool about this, actually, so that smaller galaxy is called NGC 5195. Not a fancy name. It actually, NGC is the new general catalog, and it is another astronomical catalog for looking at objects. Like we were talking about the Messier catalog. But what's cool about this is it looks like the smaller galaxy is pulling on the arm, on one of the arms of this massive spiral galaxy. But the Hubble Space Telescope has actually imaged and revealed that the smaller galaxy is passing behind the Whirlpool galaxy, this bigger spiral galaxy. And it's actually been doing this for hundreds of millions of years. So what's really interesting is it's sort of this optical illusion we have happening here. It's sort of drifting past, and its gravity, it starts to disturb the whirlpool's disk that we see that's made up of all the stars and the gas and the dust. And it starts to send out these ripple like waves similar to, well, those in a pond or like a swimming pool, like we were talking about. If you wanted to try and make a whirlpool with your friends in the swimming pool. So yeah, okay, let's see. Let me see what the chat is saying. Will they unmerge after they merge? What an incredible question. Jeff Weiss, that is such an interesting thing to think about. So we can definitely have our fact checker double check this, but from my knowledge and my experience of studying galaxies, they do not unmerge after they merge. Once they collide, they do become one image or one, sorry, reading that beautiful Hubble image of M51 in the chat. Definitely check that one out, guys. But once they merge, they become one galaxy. And it usually ends up being a little irregular in shape, kind of looks a little weird. And there are a lot in space that exist that are galaxies that have already merged. And what's so cool about that is when you look at space, you're seeing sort of the past, the present, and the future. You know, you're seeing galaxies that have already merged, galaxies like this that have not merged just yet. And galaxies actually like these that are in the process of merging and becoming one, which is incredible. We got TXR says their gravity distorts each other's shapes, triggering increased star formation, eventually merging into a single larger galaxy. Yeah, so pretty incredible. So in, millions of years, the Whirlpool Galaxy and NGC 5195 are going to be one pretty cool galaxy together. Now, what's interesting about this is these waves, they start to compress gas clouds along the inner edges of the spiral arms, triggering bursts of star formation, as we just mentioned. Now, if you look at the Hubble image, this is what's seen as sort of these bright pink regions. It's a little hard to make out in this view of my telescope here. So I'm not using a space telescope at the moment, but we can see where those regions would be. So let's zoom in a little bit. It's kind of where the blotches of brightness are in the spiral arms of the bigger galaxies. So you have these sort of blotches. Let's see if I can get my arrow on screen. Yeah. So you have right around like here. And if we zoom out a little bit, the blotches would be right about here. This is where you start to have bursts of star formation happening. And so these are regions, if again you check out the Hubble image, you start to see bright pink areas. Those are bursts of star formation that are starting to happen in that galaxy. And massive newborn stars clear out surrounding dust with intense radiation and stellar winds and shock waves from supernovae. And it leaves behind these bright blue star clusters that start to light up the spiral arms. So again, I encourage you to go check out other images of M51, the Whirlpool Galaxy here, taken by space telescopes, because you really could see it in so much more detail. Now, I did mention supernovae. Anyone in chat want to share what is a supernova? What is a supernova? It's gonna go supernova. It's so incredible. It's actually the tapestry on my wall behind me is an artist rendition of a supernova. It is such a beautiful event. Also, checking out the chat real quick. I see yes, so how far is this from Earth? All right, let's get into that. Okay, amazing. You guys are saying beautiful. M51 is just so beautiful. So this is located about 23 million light years away from Earth. And for a little bit of a recap of a light year, anyone want to share in the chat what is a light year? I've got a definition in front of me, but what is a light year? Now, it could just look at the name. Very helpful to look at the name, light year, the amount of light and how it travels within a year. So it's basically a unit used for astronomical distances, and it's equivalent to the distance that light travels in 1 year. And that's about 9.5 times 10 to the 12 kilometers. So that's nearly 6 trillion miles. And a light year is the distance, again, that light travels in 1 year. So it's really helpful to think about that when it comes to space, because if something is, 5 light years away, if you're moving at the speed of light, then it's going to take you 5 years to get there. Now, we don't unfortunately have the technology for us to travel at the speed of light as human beings, but, of course, maybe one day we can figure out some cool Star Trek thing where we can actually teleport ourselves and move close to the speed of light or something similar. All right, everyone. Should we move to the next item, the next object, the next astronomical object? Now, we are doing deep sky observing this evening. That means we are looking at objects very far away in the cosmos, far away in our own galaxy, galaxies that are beyond our own galaxy, like this right here. So we are doing some deep sky observing. So we are looking at really, really far away objects. And let's see, Robert says, is the speed of light 300,000 kilometers per hour? It's ever seemed to remember that number. Yes, yes, amazing. Good job remembering that number. I wish I actually wore my necklace. I have a necklace that has the speed of light written on it. So yes, great job with remembering that. Teleportation, MC says, and speed seem, yes, that's going to be a pretty interesting thing to try and do teleportation and, of course, maintain that speed. So we're going to look at a live viewing of this telescope now. We have clear skies. The haze has cleared. So I think actually all that technical difficulty really was just to give us time for the sky to clear up, because we really needed to get this incredible view of Bode's galaxy. As you can see, by the way, down here, This image has been processing for 12 and a half minutes. You see this pop up that just happened? So that says enhanced vision has been disrupted. It is very windy in my area. It just picked up. And so that is shaking the telescope a little bit. Probably should put some weights on it at some point. But I'm using the Unistellar app. So I shared it in the chat for the last live stream. Let me just share it real quick. So I'm using a digital refractor telescope. This is a Unistellar Equinox 2 telescope. I've had it for several years. I absolutely love it. So there it is right there. And um, something cool is that the telescope also has I have a solar filter for it. So I've also imaged the sun and the solar eclipse with it before. But it's basically a digital telescope in a way where it connects to an app on my phone or my tablet, which I'm using right now, and to actually bring us what we're seeing on the screen. And it snaps several images of the same object and stacks them to do real time image processing. So that's again what this enhanced feature is down here. It's enhanced vision. And I'm going to snap another picture right here, which I can always share with you guys afterwards so you can see what we imaged this evening. But it's super cool. Images it in real times. It's a reflector telescope, as I mentioned. So it's filled with mirrors to reflect the incoming light we see from space objects, which I corrected myself. I may have actually said refractor real quick earlier, but it is a reflector telescope and digital. So let's jump into Bode's Galaxy. Anyone know anything about Bode's Galaxy? So we just looked at two separate galaxies, and now we're going to look at one massive, massive galaxy about 11.6 million light years away from Earth. Really, really far away. Can you guess what kind of galaxy it is by looking at this image here? I'm going to zoom in just a little bit. I don't want to, there we go. I don't want to disturb it too much. There we go. We're going to zoom in just a bit. And let me know if you want me to keep it zoomed in or a little zoomed out, or what you can see better. But what kind of galaxy do you think this is? Are you able to see any sort of shape to this galaxy? This is great. Okay, amazing. Yes. Okay, we're talking about speed of light. This is awesome. Oh, so it says, let's go to the cigar galaxy. Yes, I was looking at the cigar galaxy the other evening, and I believe at this point it might be a little bit tricky for me to see. So we're gonna stick to Bode's galaxy for now. But yes, Carrie Ann. Oh my gosh, Carrie Ann. Is that my friend in California? Carrie Ann. It is a spiral galaxy, yes. And Mateo, it is a spiral galaxy. Amazing. Yeah. So you can see if you zoom in just a little bit, you can see a little bit of a spiral arm happening right around here on this edge. Maybe if I zoom out, actually, it might look a little better. And then you got another arm down here. Now, as it processes more, you can actually see it a little bit longer and you can start to see the details of it too. And so this is a pretty incredible galaxy. You should be able to see it with binoculars under dark skies because it has an apparent magnitude of 6.9. So 6.9 is the apparent magnitude, which means that you can see it with some binoculars. Does anyone want a quick recap of apparent magnitude? I'll go ahead and just actually put this in the chat real quick, but it's basically how bright an object appears from Earth um, as opposed to absolute magnitude. Oh, Carrie Ann, friend from Canada. Yes, hello, Carrie Ann from Canada. That's amazing. Where in Canada are you watching from? Is incredible. So you probably have maybe dark skies by now, unless you're around the Pacific coast. Then you may just now be experiencing sunset. But yeah, so apparent magnitude. So that's right at about 6.9. So if you were to go outside with the pair of binoculars, you should be able to see Bode's galaxy. Now, this is a pretty large galaxy. It's about 90,000 light years in diameter. So about 90,000 light years across. And what do you think is in the middle? What do you think is bright, bright, bright region? It's like what's there? I'm sure you guys probably know, so I'm excited to see with enhanced vision disrupted. I know Yes, I know, I'm aware. Lots of wind outside, but it's working. So TXR, black hole, Carrie Ann, black hole. Yes, Joe Willie, black hole. Oh my gosh. Devani Jackson, super massive bright hole. Okay, it's a super massive black hole. Yes, amazing. Awesome, awesome. Yes, it is a super massive black hole found at the center of the galaxy. Does anyone want to guess how massive this supermassive black hole is? Now we'll do it in solar masses. So give me a number like, 10 solar masses, 100 solar masses, and get crazy with the number because remember, it's a super massive black hole. So it has the name supermassive. So it's going to be a big number. I want to just see it in the chat. Give me numbers. What do you think is okay? We got 500 XR suns from Tony K 421. TXR 1 trillion solar masses, Jeff Wife 100 million solar masses. Oh my goodness, so many. Yes, 72 solar masses. All right, amazing. So many amazing guesses. All right, you guys ready? Drum roll. How big is it? About 70 million solar masses. So that's like 70 million suns combined. 70 million. So who was the closest? Someone said 72. So someone says 72 solar masses. Jeffrey, if only you put the word million in there, you would have been so close. TXR, 70 million suns. Yeah. So let's really think about that for a second. 70 million suns. It's really hard to think about. Again, we got one of our suns, and our sun is huge. Tomorrow when you go outside and you step in the sun, really think about how much energy is coming from it, from how hot you get when you stand in the sun. Well, imagine just like 10 of them, 70 of them, 100 of them, a million, 70 million solar masses. So this is a very, very active region of the galaxy. And it's actually about 15 times the mass of the black hole at the center of our galaxy. It's about 15 times more massive than Sagittarius A with a little star on top. I don't know if you guys know, I should have asked you, what is the name of the supermassive black hole at the center of our galaxy, the Milky Way? Sagittarius A. And so this is actually bigger. This is supermassive black hole is way bigger. Now, I want to ask you guys, have you heard of an active galactic nucleus before? Let's see. Active galactic nucleus, AGN. It sounds fancy. Yes, totally. Yes, sounds okay. A lot of people saying yes. Brain trying to compute. What is an active galactic nucleus? Let's really break down the words active galactic nucleus. Active galactic nucleus. And let's define it. What is an active galactic nucleus? Sorry for, totally spamming the chat with those three separate words, but active galactic nucleus. So, okay, feeding black hole. Yeah, exactly. So that definitely is something that's happening at the center. Well, for one, you have galactic there. So, okay, well, we're looking at a galaxy. So that's where the name galactic comes from. And then you have nucleus. And where is the nucleus of something? What is the nucleus of anything when you refer to it as? Scooby-Doo is in the chat. Scooby-Doo. Oh my gosh. Hello, Scooby-Doo. TXR, the center. Yeah. So you got the center of a galaxy, and the last word is active. So what is it? It's very active. It has a lot of stuff going on. It's very energetic. There we go. Trying to zoom out for you all. So it's very energetic. It's very active. This is a centered region of the galaxy, and it's powered by that supermassive black hole that we were talking about. But how is it powered by this supermassive black hole? What do you guys know about black holes? What do black holes do? Do they just exist in space and that's it? Or do they bother anything around them? Do they disturb space-time? Do they take anything from the surrounding areas of space, or do they put out anything? What do black holes do? Yeah. Spastor. They suck. They bend light, gravitational lensing. Amazing. Yes. Consume. Yes. Amazing. Yeah. Okay. Awesome. So yeah, you guys are right. You're right. You're right on the nail. So yeah, it's gobbling up matter. So it is accreting matter or gobbling up space stuff, stuff that is nearby the black hole, stars, you have just stellar dust, you have things like nebulae, for instance, that are made of molecular clouds. You have all this space stuff, and it's getting gobbled up by that black hole. And when it gets gobbled up, it starts to release these jets and winds into space. Now, although we can't actually see the jets and the winds here through my telescope, we can see the super bright central region where that 70 million solar mass black hole is gobbling up matter. And so, because it's gobbling up all that matter, it's causing a release of energy, of particles, of so much stuff coming out into space, and that's what's illuminating it so much for us here. So it's pretty incredible. I would definitely recommend also looking at images of Bode's galaxy taken by space telescopes, where you can see the jets spewing out materials. It's absolutely amazing. Now, what would you say about what you can notice here? Let's see. Autosave. Look at us learning all this stuff on a Friday night. Yes, totally agree. And a holiday weekend. So just want to say, yeah, major shout out to all of you being here. And of course, everyone here helping make this stream possible too. So I'm so glad you all are here. So let's see. We've got questions about black holes. Oh man, I know I would love to get into the details of black holes right now, but we unfortunately cannot image from my telescope black holes, or at least the event horizon, like the event horizon telescope has. So maybe one day I will get access to an incredible space telescope and we'll stream that here on PBS Nova. But let's see. I love the Andromeda galaxy. Yes. Okay. Amazing. Yes. Okay. Awesome. Okay. So basically, we're looking at this galaxy from sort of this angle. So you see how it's kind of like sideways? It's tilted at an angle that gives us this bird's eye view of the spiral arms. And this actually offers us like a much clearer look at the galaxy's structure, which we usually can get from like our own Milky Way, for instance. Now, there's a few other cool things about this is the individual stars and star clusters that space telescopes have been able to see. Now, even though it's 11.6 million light years away, certain space telescopes have been able to see star clusters and glowing gas regions within the galaxy itself. So let's see if we can kind of make out anything here. These brighter parts that you see up here, let's get my mouse up here, up in this region. These are actually foreground stars. These are stars that are closer to us. So these are not part of the galaxy. So do not let that fool you. And then we've got a few more things I just want to share about this. These spiral arms, they actually stretch all the way into the galaxy's core. And they contain young, hot, bluish stars that formed only in the last few million years, along with older stars from a starburst event that was measured to be about 6 million years ago. So you got old stars, and then you've got some younger stars that are forming within these spiral arms that really do extend all the way to the core, which is pretty incredible. And the last part I wanted to just sort of share here is it's a little, again, hard to see here, but if you look at images of the Hubble Space Telescope, you can kind of pick up greenish regions. And the greenish regions are actually where you have a lot of newborn star formation. So, do you guys remember what was the color in the Whirlpool galaxy of where a lot of the starburst formation, like the starburst areas, were happening, where all the newborn stars were forming? What was the color there? Do you guys remember in with M51, the Whirlpool galaxy? What was the color of that region? It was hard for us to tell really on my telescope, but we were looking um, at what it would be like for the Hubble Space Telescope. Okay, people are guessing blue. Okay, it actually was the pink regions. It was like the pinker regions, which is really interesting. And so with this one, it's actually again, check out the Hubble Space Telescope images, but the more greenish regions are actually where there's a lot of intense star formation in the Bode's galaxy. So a lot of ultraviolet light from newborn stars causes nearby hydrogen gas to glow green, which is just so incredible. And lastly, we have this last final view. We'll just zoom out a little bit, take another picture. We've got some cool details happening there. And let's head to our next object. So, you guys ready to go to our next object? Do you guys want to see a nebula or do you want to see a star cluster? Let's get a vote in the chat. Nebula or star cluster? Nebula or star cluster? Nebula or star cluster? Nebula or star cluster? Okay, let me take another picture. Oh, actually, I'm processing a picture right now. All right, got nebula, star cluster, star cluster. Wow, we got a lot of nebulae. Okay, a lot of nebula votes. All right, well, we're definitely going to do both. Let's try and head to it. And if anything, I've got a picture of it, but hopefully we can get a live viewing of it. So we are heading to something known as the Owl Nebula. Now, I absolutely love this app, by the way. We're going to see some cool transition happening when it's like heading over to the object. Once it finishes taking that image, as you can see the processing button right here. But what I like is that there's actually fun facts down here, which is pretty cool. So residue of a star, the same type as our sun. So we are heading to the Owl Nebula, which is a leftover remnant of a star that died that is very similar to our sun. Now this one's only 2,000 light years from Earth. Do you guys remember how far were the galaxies we were looking at? How far were they from Earth? I see someone saying a double cluster in Perseus, a star died. Yeah, a star died. And it became this beautiful gas cloud in space, molecular cloud. It's just colorful and absolutely majestic to look at, kind of like the tapestry behind me. 70 million. Yeah. Well, 70 million was the mass of the supermassive black hole. But yes, autosave says 11.2 million. Yeah, so the last one we're looking at was about 11.6 million light years away from Earth. So kind of looking at the distance there of these other objects. We were looking at galaxies that were millions of light years away from Earth. Another one was 23 million light years away from Earth. Oh, have we arrived? Okay, we've arrived. So I'm going to start processing that image. So we can hopefully see it come through a little bit. But yeah, we're looking at also, again, we're looking at something that was millions of light years away. Well, this one is only 2,000 light years away. Not that far at all. This is the Owl Nebula. Now, can you guess what's it going to look like? Is it going to look like an ostrich? Is it going to look like a guitar? What is this going to look like? Yeah, so we'll see. 2,000 light years is still so difficult to fathom. I totally agree with you, autosave. Kim Stone, do all galaxies spin in the same direction? Amazing question. Maybe someone in the chat can comment about that. That's so incredible. Do they spin in all the same direction? What I would say, no, probably not. But we're going to jump off galaxies right now and look at a nebula. But I think that is still a absolutely incredible question to ask, because another really interesting thing is if we wanted to really kind of get into talking about dark matter at all, and that would be in like a whole different tangent, but something that was helpful with that was sort of looking at I'm going to digress. I'm not going to get into it. All right, so we are looking at the Owl Nebula, and I don't see much. So while this image processes in real time, you know what I'm going to do? I'm going to look at my gallery. Also, all those bright yellow circles, that was the sun. That was when I imaged it during the solar eclipse. But we're going to check out an image I captured of the Owl Nebula very recently as our telescope processes the image in real time. So it is a little bit dimmer than, say, who here joined the stream in December? Just put like me or yes, or put an emoji if you were here in December when I did a live stream. TXR, me, amazing. So we looked at a different nebula. We looked at the Orion Nebula, and that was very different. So this one is the Owl Nebula. It is a planetary nebula. Why do you think it's called a planetary nebula? Planetary nebula. Why is it called a planetary nebula? Who wants to take a jab? Who wants to take a guess right here at why it's called a planetary nebula? Now, as you all are putting your answers in the chat, just a few fun facts about this. If you're looking for this in the night sky, you're going to want to look for the Ursa Major constellation. So it's going to be found within the Ursa Major constellation, and it's estimated to be about 8,000 years old. So 2,000 light years away, 8,000 years old. A few other things about it is it has an apparent magnitude of 9.9. So a little tricky to see. You'll need a telescope to see this, but it is about 1.82 light years in size. So it actually makes it one of the brighter planetary nebulae to see. Planetary nebulae are not as not as bright as, say, like the Orion Nebula. They tend to be, just from the whenever I've looked at them before, they tend to be a little bit dimmer in the sky. So definitely, if you're going to do some stargazing, use a telescope. All right, we have Marina says shape, it's round. Yes. Paul, I guess because it's a large cluster of planets. It creates planets, says Pragmatic Man. Oh, this is incredible. So you guys are guessing. Yes, it has something to do with planets, maybe. All right. Did anyone guess? Let's see. Oh, nope. Actually, no planets involved. RK Hageman. Yes, no planets involved. That's the cool thing. There actually are no planets involved. It was called a planetary nebula because it literally looked like a planet. And early astronomers, with their early versions of telescopes, they thought that this was a planet. And so astronomers we're talking the 1700s, the 1800s, when they were looking through these telescopes, these nebula, they really resembled planets. And so they actually thought they were planets. But turn out they weren't. Turn out they were leftover remnants of stars like our sun that died. And it's absolutely incredible. It does have an elliptical shape, as we can see. And so now we have a whole category of nebulae called planetary nebulae, which is pretty interesting. So they start to form basically when a low mass star begins to die and it releases its outer materials into space that start to form this shape. I like to compare it to like an onion. So like when you know how onions have all those layers to it, and you start to like peel off like the layers of the onion. So that's how I like to think about it when like our sun dies and it expands into a red giant star and it starts to lose its outer layers. That's how we start to get a shape like this in space. Is we start to have the releasing of outer materials into space, and it forms the shape of a nebula. And this one specifically, now it's like not the most. I don't know. I feel like these names are just a little bit weird. So it's called the Owl Nebula. Does anyone want to take a guess as to why it's called the Owl Nebula? Like really looking at it, like really think this through here, because I was like really skeptical. I'm like, that does not look like an owl, but there's a reason it's called the Owl Nebula. It might not look like the whole shape of an owl, but there is something about it that sort of references an owl. Oh my gosh, autosave actually guessed it right. Pragmatic Man. Okay, you guys definitely are more artistic than I am, I guess. Yes, it's like the two eyes of an owl, two big owl eyes. I feel like everyone, even though I can't see you guys, you all should just do this from home anyway and just do the big owl eyes. Yeah, these darker regions that you see here, these are supposed to kind of represent two owl eyes. I guess I kind of see it now looking at it from the computer. It does sort of look like that. So yeah, do you see these darker spots within the gas cloud? Because that's where the name came from, as being the Owl Nebula. Now, it was discovered by French astronomer Pierre Méchain in 1781. So again, we're talking 1700s here. Charles Messier. This is a Messier object, as we could see in the bottom, M97. Now, Pierre Méchain was actually a friend of Charles Messier, and this object was later added to the famous Messier catalog, and that's why it has the name M97. So it was one of the later objects that was added to the catalog, and must have been pretty cool to discover these and see these for the first time and say, "Wow, this is an incredible thing in our universe, in our sky." that is not a comet, but we should still love it and we should still look at it. Now, something interesting is it's not stagnant. It's not just in space. Its gas is actually expanding outward, and it's expanding outward pretty fast. Does anyone want to guess how fast it is? You can give me kilometers per second or miles per hour, whatever you're more comfortable with sharing. But how fast do you think the gas is being pushed outward and expanding of this nebula? All right, at least 5 miles per hour. Yes, wow, that's a very, very slow. That's very slow, definitely. I mean, that's great. That's great. 126,000 miles per hour. That's fast. That's very fast. Paul says 3,000 kilometers per second. TXR, faster than a bird. This is so great. Yeah, I think it's actually pretty cool to sort of think about it in a way of faster than certain animals. All right, are you guys ready for how fast it is? I'm going to give it to you in miles per hour in the chat. 60,000 to about 87,000 miles per hour. So can you imagine being like in this nebula and then just like all this gas cloud is just like being pushed out like super, super fast. And for my friends who obviously would prefer the metric system, here we go in kilometers per second. So it was formed when the central star neared the end of its life. Like we said, it was dying. It shedded out its outer gas layers. Think about an onion. And over thousands of years, stellar winds blew these layers into space. And the remaining core of the star is actually starting to contract. And it's actually going to become a white dwarf. So can you guys see it? I can see it sort of like between the eyes. So unfortunately, I can't like zoom and readjust it. So you're going to have to just like look, wait, this way. Yeah. I just realized I'm not on a green screen. I'm so used to filming green screen, but I can't point to it. But I can use my mouse right here. So that would be, then this would be my guess of where that central star is. Oh, native tech says I can see it. Yeah, amazing. So that right there is where that central star is. That was the core of the star that died. That right there. And that is starting to get more and more condensed, and it is turning into a white dwarf star. Ultraviolet radiation from its hot core ionizes the ejected gas, and so it causes it to glow like this. And this is what creates the visible planetary nebula that we see. So absolutely incredible stuff. We still have a lot of movement within this nebula. And that's about, whoop, that was Mars from the other night. There we go. And that's about everything that I want to share for this object, at least for the Owl Nebula. But we're going to move on to our next object, which is our star cluster. Are you guys ready for the star cluster? This is so great. Okay, so let's see. Yeah, it looks similar, pragmatic man, to the one that's on the wall behind me. Now this is an artist rendition, so it's actually not a real image. There are real images that you could actually print this big, but this one is an artist rendition of one. This reminds me a lot of like the Crab Nebula, which is pretty cool. But this one here is a planetary nebula. All right, so this was an image. Let me just go to live watch real quick. Yeah, it looks like my enhanced vision is getting disrupted. That's fine. We are going to head to a cluster. So we have, let's see. So we are supposed to be, because we're going a little bit later than usual right now. So I'm going to see if M3 is available in our sky still. It might not be. Oh yeah, high elevation. All right, let's see. We're going to just head on over to it. So we do have some trees here, a little bit of buildings kind of working around. But if you guys ever go out stargazing, definitely try and find an area where you're able to get up a little bit higher elevation, or out maybe like on a lake where you have a lot of sky, where you can see the sky all the way down to the horizon, because then you have a greater chance of seeing more stars. Now I'm doing this stream from home, so I'm working from my backyard. However, I went comet hunting back in September and I went out to a lake and it was absolutely incredible because the comet was super low on the horizon, only visible for like 30 minutes, and then it vanished. I couldn't see it because of where it was located on my horizon, and it just got too low. But it was so amazing. And so I highly recommend, if you guys are going to go out stargazing, go to a dark sky location. There are certified dark sky locations. They're usually state parks, national parks. And yeah, go camping. It's absolutely incredible to do it. Bring a telescope, bring some binoculars, and just look up at the night sky. So as you can see, we are heading to M3. So let's see what we've got. I love this in the chat. This is so incredible what you guys are talking about right now. So, right, nebula would be better name for the category. M3 is located in the yes, Canes Venatici. Yeah, a constellation near the North Galactic Pole, about 11 degrees northwest of the star Arcturus. Matteo, you definitely get out and look at the night sky. That is amazing. Yes, so this cluster, which hopefully we're able to zoom in on right now. We're going to do the enhanced vision real quick. So this is located about 33, almost 34,000 light years from Earth. So 33,900 light years from Earth. And it has an apparent magnitude of 6.2. So if you guys remember before, we were talking about apparent magnitude. And that means it can be visible with binoculars under certain dark skies. So it can be, might not be for everyone, but it's possible. You should be able to see it. And it is a star cluster, but what kind of star cluster is it? I'm going to let this image process, and I'm going to bring you to an image I got of it also the other night. So let's go back up here. What kind of star cluster do you think this is? Just by looking at it. There are a couple different categories of star clusters. What would you say this is? Let's see. So Marina says, we saw it without binoculars in the middle of Sacramento. It was very bright. That's incredible. Hard to find dark sky in the East Coast. Yes, West Texas, super dark. Pragmatic man, totally. Our star is made of helium, which is, yes, Kim Stone, amazing. Super dense. Wow, pretty one. Oh, pretty. I love that. Life is good. That's great. A lot of star clusters. Okay. All right. Bye, RK Hagman. So yes, Tim L. It is a globular cluster. A globular cluster. Why do you think the name globular cluster exists? Where do you think it comes from? So I'm going to grab this right here. I'm going to grab Mercury. So this right here is Mercury. Everyone say hello to Mercury. Hello, Mercury. So I've got a few different globes. I also have Neptune and Earth up there. But yeah, it looks like a globe. It looks like a globe. It's a globe-like in shape. And so that's actually where the name comes from. Autosave. Hi, Mercury. So it's a globular cluster, and globular clusters are the older clusters. So if you were here in December, we looked at the Pleiades open star cluster, and those are younger clusters. They are made of younger stars. This one's a little bit different. It is a massive star cluster. And by massive, I mean this has about 500,000 stars and has a brightness of about 300,000 suns combined. So 300,000 of our suns, just one sun, 300,000. So it's very, very bright. And it has all of these older stars in it. Put Mercury back. Okay. And so it's extremely bright. I love that someone in the chat literally said that they were able to see it the other evening as well. So it's definitely something you can catch in your night sky. It is so brilliant to look at. And it is, let's see, it is, yeah. Okay, let me see what the chat is saying here. We've got, what blows my mind is that there are hundreds of unknown planets around those stars that we'll never know about in this lifetime. Yeah, that really blows my mind too, is thinking about how many stars are in the universe and how many of those stars have planets around them. Actually, that's what first inspired me to get into astronomy when I was 12 years old. It was because I had this realization of just how big our universe was. And I thought there's got to be other planets out there like Earth with life on it. And I just had this like just mind blown moment and thought, oh my gosh, I have to try and be part of this mission as a human being. This is like the most important job I could do for research and advancement of the human species, is to try and find life beyond Earth. Does it exist? How do we find those planets? And it's so amazing to think about. So anyway, back to this. So we're talking about how old this cluster is. So it's estimated to be between 8 to 12 billion years old. And that's really impressive. How old is our universe? How old is our universe, you guys? Because that's really, really impressive to think about. That this can be anywhere, it's estimated between 8 to 12 billion years old. Well, our universe is about 13.7 billion years old. That's so it's like right about like the same kind of ballpark as the age of our universe. And so it is definitely an old cluster, and it's made of older stars. So okay, we get it. It's old, but they're also huge. Globular clusters can contain like tens of thousands to even millions of stars. I mean, millions. When we looked at the Pleiades, that was just a couple. That was about 1,000 stars in the cluster. This can have up to millions of stars, and with all of those stars, it can take up a lot of space. Literally, it can stretch out from 50 light years to 450 light years. It can take up a lot of space. How big do you think M3 is? How big do you think M3 is? Well, this is M3. It actually is about 190 light years across. So it's actually really, really big. It's a relatively large cluster. And it's really big. It's really bright. And it has a lot of stars in it. Oh, another cool thing, it's actually headed this way. It's headed towards us. Now, don't worry, it's still, space is massive. So we are fine. But it is actually headed this way at 147.6 kilometers per second. So, uh-oh. Yeah, no, it can stay out there. Yes, no, stay out there. But yeah, absolutely incredible that this cluster is also moving. And it's old and it's beautiful and it's filled with a lot of stars. I'm trying to zoom out. There we go. So you can kind of see the whole picture of all the different stars within it. Now, this is a Messier. You see the name M3. So, if anyone had a guess, if we learned anything this evening, Messier catalog, what year was it discovered? If you had to guess, you can give me a ballpark. It's fine. It doesn't have to be exact, but I will tell you that it was discovered by Charles Messier himself, and it actually was the first object added to the Messier catalog. So, it was discovered by him. So what year was Messier around? Just give me a guess. And it also was the 75th object, deep sky object ever discovered at the time of its discovery. So when a lot of deep sky objects are being discovered, this one was the 75th one. All right, we got late 1700s, 1880, 1824. Yeah, it was late 1700s. It was 1764. So 1764 is when it was discovered. So pretty incredible. A couple other things I wanted to ask you guys or share with you is, where are these clusters located? If you had to guess, where are these clusters located? 2001: A Space Odyssey. Gas clouds come from a red giant. Let's see, in the sky, up. Yes, I mean, of course, it is located in the sky. Let's see where. Okay, so they're located in space. Um, where in a galaxy would these be located? Where in a galaxy would these be located? If you had to guess. So they are found, globular clusters are found in galaxies. So we do see them in galaxies. But where in the galaxy is kind of the more important question. What would you have to say? Where in the galaxy would it be located? All right, far, far away. Core. In the core, in the upper part, something other than the Milky Way. Okay, let's see. In the core, but also we got a few guesses in the core. 2/3 from the center. Okay, amazing. Denise, you are right. The halo. In the halo, I feel like I should have like a soundboard where I could play music. It'd be pretty nice. But yes, globular clusters tend to be found in a region known as the halo of galaxies. And this is actually the outer region of a galaxy. And if we actually were to go back, let's just for fun let's go to a galaxy image. So let's go back to Bode's galaxy. The halo would be this outer region of the galaxy, so right around the outer edges. And a lot of globular clusters are found in this region. And there are even some in our home galaxy, the Milky Way. There are tons of globular clusters actually found. And once a globular cluster forms, they actually no longer contain the gas and the dust needed to create new stars. So a lot of the stars that exist, they all really formed at the same time. They're all like the same age, they're all in the same neighborhood, they're all friends, they all know each other, they all grew up around the same time. And so what's pretty cool is there is some evidence that suggests that a few clusters may have formed more than one generation of stars early in their history. So there could be several generations of stars in the early formation of a globular cluster. But again, found in this sort of outer region of a galaxy known as the halo. But let's wrap up here on M3, and then we'll move to our final object of the evening. But just one more thing to share. How many globular clusters do you think are in the Milky Way galaxy? How many globular clusters? So give me a number. How many globular clusters are in the Milky Way galaxy? Now, they actually have retrograde orbits. Many orbit in the opposite direction of most stars. And this actually hints that they were probably captured from other galaxies during interactions of merging of galaxies, like the one we looked at earlier, the whirlpool galaxy. So when they're merging, a lot of times they can get captured, and this will cause them to be in a retrograde orbit. So they are orbiting in an opposite direction of a lot of the stars. So how many stars? We have 1.5 million. Wow. Ben says 1.5 million. Sean says millions. Jeff Weiss says 100,000. Autosave says 100,000. Prize Picks is 30. Colin says 2343. Mateo says 160, then 150. So Mateo is correct. Mateo, it is 150 known globular clusters in the Milky Way galaxy. So there are 150 known globular clusters. Yeah, incredible. Amazing, amazing. Yes, Ben, those are very, very big guesses. Autosave, Jeff Weiss, definitely big guesses. But, I mean, we got to think big. The universe is massive. So we got to think big. All right, we are going to head to our final object of the evening. What do you think our final object is? What do you guys think? Now, I am going to head to, it has already set by us. So I'm actually going to head to the image that we took. Let me just see what the telescope's seeing. Yeah. Nope. Disrupted, enhanced vision, winds. That's okay. We've got images here. Oh, look at that cool whirlpool galaxy picture. That's amazing. All right. What are we looking at? Mars. No, we're not going to look at Mars. Although if we wanted to just for fun real quick, we do have a Mars picture right here. But we are actually going to look at this gorgeous, beautiful, bright star, Pollux. This is a very beautiful star. It is a hypergiant star. So I figured we looked at big galaxy mergers, and then individual galaxies, and then clusters of stars that live in those galaxies. And now we look at an individual star. Oh, and we looked at the death of a star, which was the nebula. But we are going to look at this beautiful, beautiful star. Now, I chose this star because it is beautiful to see in the evening sky right now. It is the twin star of Gemini. So if you look at the Gemini constellation, you can actually see this star. It is the brightest in the constellation, and it's actually one of the brightest in the night sky. So you can definitely see it without a telescope or binoculars. If you're looking up in an area where there's not a lot of light pollution, and you're able to see the night sky clearly, then you should be able to see the star. Now, something pretty cool about this star is it actually hosts an exoplanet. So it hosts an exoplanet. Isn't that amazing? Someone mentioned earlier, just looking at the star clusters, is just how many of those stars have planets around them. This one does. This one has an exoplanet. Yeah, amazing. So, and I see we just got another question in the chat about the telescope we are using. We are using the Unistellar Equinox 2. So if you wanted to check that out, it's an Evoscope. We believe we attached a link somewhere high up in the chat. We might be able to reattach that link soon. But this star is incredible. Not only is it super bright, you can see it in the night sky. It's part of the Gemini constellation. It is actually the brightest star in the Gemini constellation. But what's funny is it's actually called the Beta Geminorum. So the Beta is usually the second brightest star in the constellation. Normally, that's what the label goes to, and the Alpha is usually the brightest, which for some reason it was actually given to Castor, not Pollux. And Castor and Pollux are those two bright stars in the Gemini constellation. They're kind of like the upper shoulders of the constellation. I like to say the shoulders, but it's like the top two parts of the constellation. And it's funny because Castor is actually dimmer, but that one was seen as the Alpha, and this one is the Beta of the Gemini constellation. But it's not just a bright star. It's actually very big. It's large. It's a hypergiant star. It's about 1.9 times the mass of our sun, but it's also much wider. It's about 9 times the sun's diameter. I'm going to share that in the chat so you guys can look at it also. It is super big. So it's 9 times the sun's diameter. So imagine our sun and then 9 times the diameter and 1.9 times the mass of it. So it is really, really wide. It's a pretty big star. So that's why also we're able to see it so well. Thank you for sharing the Unistellar Digital Telescope in the chat. Thank you. Amazing. Bob Gang. Yes. So it has at least one telescope. Amazing. And let's see, we've got a few other, just checking the chat. Amazing. Yeah. So this is a really beautiful star to look at. That's why I chose it. I absolutely love it. But now we're going to talk a little bit about its classification. Does anyone have experience in stellar astrophysics? Has anyone taken a class before? Is anyone here, doing astronomy in school, by the way? Or does anyone have a telescope? If you do, comment it in the chat. What telescope do you use? I would love to know what telescope you use and what's your favorite space object too. But if you are studying astronomy in school, you may be familiar with what type of star this is. So this is a KO3b star, and this means that it is a giant star that's slightly dimmer than others in its category. So the KO part tells us that it's cooler, and it's a yellow-orange star. So can you actually tell that by the screen? Can you tell that it's kind of a yellow-orange color? Just a little bit yellow-orange here, a little bit yellow-orange. I think the color comes through pretty well. It definitely does not look blue on the screen. I can tell you that. It is a yellow-orange star. Let me just recenter this. There we go. I'd say a bit more tangerine. Yeah, I mean, it could look a little more tangerine. I just love how brilliant it looks. It's so shiny. And so anyway, so Pollux, the KO is, again, tells us that it's a slightly cooler star and it's a yellow-orange star. So how much cooler is it? Well, it is cooler than the sun's surface temperature. So it's about 8,000 degrees Fahrenheit or 4,400 degrees Celsius. And compared to the sun has a surface temperature of about 10,000 degrees Fahrenheit. That's 5,500 degrees Celsius. So it is definitely cooler than the sun, but it shines brighter. So it's about 45 times more luminous than the sun. So it's much brighter. And again, it probably has to do with that size. We're talking about like its diameter and just how big it is. So if we were the same distance from Earth, Pollux would actually look 3 times brighter than the sun. So imagine, just like picture it for a moment. Has anyone ever played with Universe Sandbox before? Anyone know what that is? If anyone comments in the chat and is like, I know Universe Sandbox, I love that, then you would know that swapping out the sun is like the coolest thing ever. I always loved swapping out the sun for a black hole and just to see what happens to the solar system. It's really cool. But if you were to instead put Pollux in place, it would be significantly brighter. It'd be about 3 times brighter than our sun. I can't imagine beach days. It'd be way too hot. So moving on, Pollux is actually a pretty young star also. So it's only estimated to be about 725 million years old. So it's not in the billions, it's in the millions with an M, 725 million years old. And so compared to our sun is about 4.6 billion years old. So think about that. I'm going to put this number in the chat so you kind of like really visualize it rather than just sort of hearing it from me. But here, let me put Pollux. So Pollux about 725 million. And then you have the sun, which is 4.6 billion years old. So that's a big difference in age when it comes to space. Especially when it comes to us humans who only live for like 100 years, if we're lucky. So it's a really big difference for stars. But what's incredible is that even though it's a younger star, Pollux has already moved past something known as the main sequence. Does anyone know about the main sequence stage? What is the main sequence? Where are my stellar astrophysicists in the chat? Anyone have taken stellar astrophysics? Me, yes, you, anyone? What is the main sequence stage? So to give you a hint, the sun, our sun is a main sequence star. It is in the main sequence stage. And this gets all fancy and technical. It goes into something known as the HR diagram or Hertzsprung-Russell diagram. But it's really helpful when it comes to understanding these stars, classifying them, understanding their temperatures and how they're going to die. And, if they're stable for an exoplanet to have an atmosphere around it, especially because this one does have an exoplanet orbiting it. It's really important to know the classifications of these stars because you want to know, okay, is that planet within a safe region from that star where an atmosphere can happen and life can exist and life can flourish. So anyway, so let's see. Main sequence stars, Matteo says, are stars that are in the longest, most stable phase of their life cycle, a stage where they fuse hydrogen into helium in their cores. Amazing. Yes, that's incredible. So that's completely correct. It's when the star is fusing hydrogen and making helium. This is very stable for a star. This is really important for a star's life. This is a stable part of the star. If they're able to fuse hydrogen to helium, they are doing good. They are stable. They're a stable star. Now, what's interesting is Pollux has moved past the main sequence star. And so it's now moved past its main sequence stage. And so this star, again, it's this sort of yellow orange star. It's extremely bright. We should be monitoring it, kind of checking it out, seeing what is the end of its life going to look like. We can kind of explore that just a little bit, but it's significantly younger than the sun. So I think that makes it pretty unique also. And just kind of thinking about, again, like when stars begin to die, you start to see they reach a point where they no longer can fuse certain elements to form new elements. And this is when stars become unstable. And a lot of times they begin to die, whether they explode as a supernova or they expand into a red giant and slowly die. So like I said, the sun is going to eventually expand into a red giant star and puff out its outer layers and form a planetary nebula. Betelgeuse, Jeffrey, yes. Betelgeuse was on my list of the evening, except that it sets way too early in the evening and the sky was not getting dark enough for me. So we were not able to look at Betelgeuse. But Betelgeuse really is a good one. Betelgeuse is absolutely amazing star, but we'll get into that another time. So I just have one more fun fact to share here, and then we're going to wrap it up for the evening. So back in 2009, astronomers found that Pollux, again, the star we're looking at, has an incredibly weak magnetic field. So it has a really, really weak magnetic field. It's actually one of the weakest ever recorded for a star. It's less than 1 Gauss. And for comparison, the sun's magnetic field is about 10 Gauss. And Earth's magnetic field is between zero point 0.5 and zero point 0.6. So this star, it's similar in strength to Earth's, but significantly weaker than the sun's. And if anyone has ever looked at the sun before and has seen sunspots, this is something to keep in mind when it comes to magnetic fields. So, with our magnetic fields we have around the Earth, the sun has a magnetic field. And actually, when stellar wind comes in from a solar flare, and interacts with Earth's magnetic field, that's what causes the northern lights or the aurora borealis. Same thing, different name. It's because of the interaction of the particles within that magnetic field with the stellar wind. So we have a lot of things to study in space when it comes to magnetic fields of stars and of planets. And this is one of the weakest ever recorded for a star. So that is the last fun fact I had for the evening for this object. I just want to say, first of all, thank you all so much for joining the stream, despite the technical difficulties, and having to change for a few different streams back and forth. Excuse me. And doing different links. It's amazing that you're all here. I'm so glad you guys stayed here. I'm going to do a quick recap of all the objects we looked at this evening. We looked at M81 Bode's galaxy, absolutely incredible galaxy. Then we looked at a galaxy merger. We looked at the Whirlpool galaxy. That's two galaxies combining into one. We then looked at the star cluster. Actually, I'm going to look at first the Owl Nebula, a planetary nebula that looks like two eyes of an owl. And then we looked over at Pollux, a hypergiant star that it has a weak magnetic field. And then we looked at M3, a globular cluster, one of the oldest globular clusters ever recorded. So I just want to say to you all, thank you so much. I hope you guys feel maybe a little bit inspired to look up at the night sky from your own backyard this evening. The whole reason we do this stream and we love sharing this cool stuff about space, personally, why I love sharing this cool stuff about space is because I just want more people to look up, more people to look at our beautiful cosmos and to ask questions and to learn more about our universe. As a little cool thing here, I've got a little meteorite I want to show you all that I use just on my desk every now and then as a paperweight. But I brought it up here just to sort of show you guys because I think it's super cool and nerdy, and I figured you all would appreciate it as well. But thank you all so much. I hope you guys have a wonderful evening. As always, make sure you look up at the sky. Think about our universe. Think about how wonderful it is to be alive, to be on a planet like Earth, and to be in a universe like ours. So thank you all so much. Stay tuned for new episodes of What the Physics coming out on PBS Nova, and I will talk to you all soon. Have an amazing weekend, and I will chat with you guys in the future. Ad Astra. Bye, guys. See you later. Goodbye, everyone. A meteorite one more time. Okay. All right. Signing off. Bye.